Okay, so hopefully everybody's following our concepts related to object-oriented programming so far. Okay, so hopefully today we'll finish the basic object-oriented programming and start to take a look at slightly more involved things. Three concepts in basic object-oriented programming as far as C# is concerned, encapsulation. So by now you guys hopefully know it very well. This is basically creating a class so that related code and related variables are put together in a virtual box, right, or are encapsulated. So here we have public, private, protected type of keywords. So everybody hopefully understands when to use public, when to use private, when to use protected. Very quickly, if you created a class and if you're declaring a variable inside it, how should it be declared?
Private.
Private, okay. If you're writing some function in it or a method in it, so public, let's say double compute. So the methods are usually declared public. Okay, so even though there are cases where for some reason you may make data public and a method private, but most of the time data will be private and the methods will be public, right? Okay, so as far as C# is concerned, we had a concept of properties over here. Okay, so a property, if you recall, was a tiny get and set part associated with a private variable. So the convention was private variable will start lowercase, the corresponding public property will be uppercase, and of course the property has to be public, right? Okay, because it's like a small function. So anyway, that was encapsulation. Then we looked at inheritance, and here the idea was if we are creating many classes with some methods and some data in it. So as we start to create more than one class, there's a possibility that a few of these are being repeated, right? So if the blue part is the same as in this class as the second class, then that's the time we take that part out and create a base class. And then using the colon syntax, so if this was, let's say, class, let's say Y, then if we call it class, let's say my base. So anyway, then we'll simply say this inherits from my base. And then since the common part has been moved over here, there's no need to write this. Same way over here, this will be inheriting from this class as well, so it minimizes the amount of code. So anyway, hopefully everybody feels very comfortable with where to start. Okay, so what's our starting point? Our starting point when we are writing many classes is to identify the real entities that we need to model in our software and create a class for those. As you start to create more classes, you yourself will discover what should be a proper base class. Okay. Anyway, as we went to inheritance, we needed a few more keywords. Okay, what were those keywords? For example, virtual, abstract, and override. Okay. So virtual, if this is the top level method over here that we moved over here, and there is a real code in it, we'll mark it as virtual. If the two methods have the same signature over here, but the code is different, so as we move it to the base class, then that will be marked as abstract because we cannot put any code in it. It differs between the other two classes, right? And lastly, as we are inheriting and changing the code, we mark it as abstract, right? So anyway, through our university example, hopefully everybody feels very comfortable with it. And now, last lecture, we were looking at polymorphism. Okay, polymorphism, there's a theoretical meaning of it, there's a more practical meaning of it. The theoretical meaning was that more than one function with the same name, correct? So more than one function with same name. Okay. So where does this occur? It can occur within the same class. It can occur once we are doing inheritance, meaning writing many classes. Okay. Within same class. Okay. So this concept is called overloading. So if we are writing many functions with the same name, but different parameters, we refer to it as overloading a method. Okay? If we are between a base and a derived class, so as we have one method, let's say in our base class, suppose this is called my base. Okay, we wrote some method over here. Okay, class, let's say my derived, inherit from my base. Okay, and we wanted to change the code over here, right? So as you guys saw over here, it has to be declared virtual, correct? Because there's code in it. So suppose the method is called f1, method is called f1. So over here, what keyword will we use?
Override.
Override. So anyway, the second concept where polymorphism occurs is that's between a base and a derived class, and the override keyword is used to indicate we have the same method, okay, same parameters, exact same parameters, okay, but different code over here. So this code is different code. So unlike overloading, where the parameters are different, in overriding, the parameters are 100% the same. Okay, the name of the function is the same, parameters are the same, but the code inside the function is different. So that's another form of polymorphism. So anyway, these were the theoretical meanings of polymorphism, right? On the more practical side, the polymorphism, as we discussed in the last lecture, occurs when a base class reference is used to point to a derived class object. Okay, so this is perfectly okay to do. In all object-oriented programming languages, this capability exists. And this is where the complication comes into play, right? So let me give you a slightly different example because in my opinion, rest of whatever we discussed was pretty straightforward. This is where, if you're new to programming, you start to become a little bit confused. Okay, so let me give you one more example. Okay, let's say you have a class called employee. Okay, and suppose you have a function over here, public double compute pay. And let's pretend over here we have two fields, hours worked, and so this could be double. So somebody could work 4.5 hours as an example, right? And the corresponding property, and let's say double pay rate. So somebody may have a pay rate of, let's say, $12.50 per hour. So $12.50 might be the pay rate. hours worked may be, let's say, 4.5. So the purpose of this is to multiply these two and give an answer. So simple method over here. So this will be simply return hours worked times pay rate. Okay, so anyway, now let's say we also have one more class. Okay, so class, let's call it, or to make it easier, okay, let's call it full-time employee. Okay, and we inherit it from employee. So inherited from employee. So that means the hours worked pay rate is still available to us, right? And so over here, suppose we override. So public override. And if we are overriding, what does that mean? How should this be declared over here? Virtual. Okay. So anyway, public override double compute pay. So so let's pretend what we wanted to do is if somebody works more than 40 hours, they will be paid 1.5 times the hourly rate. Okay, so if your hourly rate is 12, so you will be paid $18 per hour if you work overtime. Okay, so that's the benefit of a full-time employee. Think of this as a regular employee. They do not get any overtime over here. So anyway, so our code will look something like this. If our so let's create double pay equal to 0 if hours worked, let's say, is less than equal to 40. Okay, then pay will be same as before, meaning hours worked times pay rate. Okay, else. Okay, let me go over here. Okay, so else pay will be equal to hours worked minus 40. So if somebody worked 50 hours, right? So this will be 10 times 1.5 times pay rate, correct? Plus hours worked. Sorry, 40 times pay rate. Okay, so anyway, so that's the end of the method, end of the class. Okay, so let's pretend we have two classes once again. Employee, where this is the payment method. Full-time employee, where if they work more than 40 hours, they get paid more, right? So now let's write some test code over here. So now, as far as this concept is concerned, base class reference. So what's the base class in this example? Employee. So if somebody created an employee type of reference, okay, equal to new, but however, they allocated memory for a full-time employee. Okay, and now if they said something like this, double, okay, before we call the pay, let's set some hours. So if we did E1 dot hours worked, let's say 45, or let me make it 50, easier to calculate. Okay, E1 dot pay rate say equal to 12, right? And double pay equal to E1 dot compute pay. Okay, and then message box dot show whatever pay dot toString. So this is message box dot show. Okay. Anyway, so suppose this was written in some kind of a button handler, right? Okay. So this is where the polymorphism comes into play. Okay. So take a look over here. E1 is what data type? Employee. So once the compiler makes a decision as to which compute pay should be called, should it call the compute pay in the employee class, or should it call the compute pay in the full-time employee class? Okay? So remember, since we allocated memory for the full-time, the correct answer is that it should be calling inside the compute pay. But how does compiler make that decision? Okay, compiler, as we discussed, only goes by how the variables are declared. So E1 is declared of type employee. So what will the compiler do? Before it decides which function should be called over here, it will go to the employee class. It will check how is compute pay declared. Okay, if there was no virtual over here, then what will it do? It will just call this one, okay? Because that's the meaning of the virtual keyword. Virtual keyword basically means go through the vtable to make a decision what should be the proper call. Okay, so as it sees the virtual, then it will not try to make a call to the compute pay. It will actually create quite a bit of code over here, which, as we discussed in the last lecture, so for example, employee E1 is over here. New full-time employee, we will have hours worked. In this example, we will have pay rate in this example. And what will be the extra field over here? vtable pointer. Okay, and this will point to the code area. Every class, as we discussed, will have one entry in the code for the vtable. So the vtable, how many entries will be in the vtable? Remember, vtable is a table of function pointers. Each one points to the code for whatever that function is. So for example, let's pretend we also have a public property. There will be a set, there will be a get over here, right? So there will be two set and get for the hours worked, set and get for the pay rate, and lastly there will be the code for compute pay, correct? So in this case, this entry will be pointing to the code for compute pay. Which code? The top one or the bottom one? What type of object was this? A part-time employee or full-time employee? See, this was full-time employee, right? So this vtable will be pointing to for the full-time class. So full-time employee class, correct? Okay, so obviously the code for compute pay, this pointer in the vtable will be pointing to this particular code over here. So anyway, so to summarize one more time, when the compiler comes across this statement, what does it do? It goes and checks E1. What type is E1? Employee. Then the compiler goes to the employee class, checks, was it declared virtual or abstract or override? Because all three cases, vtable has to be involved, okay? So if this is virtual, what will the compiler do? It will generate quite a bit of code that will start from E1. So that will start from E1, go to the actual object, go to the vtable for the full-time employee class, then locate the pointer that's pointing to the code for compute pay, which in this case will be obviously this one. And so this one will end up calling the correct function, right? Okay, so that is the real polymorphism in practice. Okay, whatever we discussed, overloading, overriding, those are very, very basic implications of the polymorphism, but the real sophistication or the complication comes into play once again when a base class reference is used to point to a derived class object, right? Okay, so that was one complicated case. The second complicated case that we discussed last time was what if there's an extra field or an extra method over here in the derived class, but we are trying to access it from the base class reference. Okay, for example, let's suppose in the full-time employee we have one extra field over here, string manager. Okay, so everybody has a manager. So let me make it M with a lowercase. Every full-time employee reports to a manager, right? And again, pretend there's a get and set for it. Okay, so now let's come over here. Okay, so what if you wanted to set E1, E.manager equal to, let's say, Johnson, as an example, right? What will happen? Will this code compile? No. Okay, remember, how does the compiler make a decision? It checks E1. E1 was of type employee. So it will go to the employee class. Is there a manager over here? No. So you will immediately get a red squiggly line over here. So this you won't be able to run this program. Okay, so how do we set it if we are only given access to the base class reference? Okay, so this is where we discussed in the last lecture, we need some runtime support so that at runtime we can check and make a decision and still be able to access it. So in C#, the polymorphism at runtime, so that we can access a field which was added in the derived class, or call a method which was added in the derived class. So this polymorphism is supported through how many keywords?
3.
3 keywords again. Is operator, as operator, and the plain reflection. Okay. So as we discussed, this code won't even compile. So this is a problem, right? So instead of writing it like this, there are a couple of choices. So let me refresh your memory again. We will say if E1 is full-time employee, so we will check, is it pointing to the full-time employee, right? Still, we cannot do, even after checking it, and by the way, this checking will again take place at runtime, meaning it will start from the reference, will go to the actual object, go to the vtable, and as we discussed, the vtable further points to the type info. So this will check the type info to see it's pointing to the full-time employee. So actually, let me quickly put that picture again so that, because these are, like I said, these are the hardest concepts. If you're completely clear about it, rest will become pretty easy. So if this is the CPU.
Sir, the E1.hours worked and pay rate, they will be of the type employee, no?
See,
the one which you have declared.
Once this is being done, right? So let me draw the picture. Good question. You will be able to answer it yourself. So suppose this is E1, right? Employee E1. Once we say new full-time employee, in the heap area, what will happen? In our example, we have 3 fields, right? Manager, and 2 are being inherited, hours worked and pay rate. So let me draw that cleanly. Hours worked, pay rate, and manager. Okay, and then there will be the vtable pointer, the extra pointer. So this will take us to the code area. In the code area, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this will be the vtable for full-time employee class, correct? So this will be pointing to over here, right? And then, okay, so this, so these are these get and set for the, so get, for example, hours work and set hours work, right? And then same way get for the pay rate, set for the pay rate, get manager, and set manager, correct? Then the 7th entry will be for the compute pay, right? So this will be for the compute pay. And again, this will be pointing to the code for compute pay for full-time employee class. Right? Okay, so anyway, last entry will be what over here in the V table?
Type info.
So that will be the type info. So this will be basically type information. Type information for full-time employee class. So it will have a lot of information, such as name of the class, how many methods it has, how many properties it has, and so on, right? So a lot of information over here. So anyway, now let's try to answer your question. Okay, let's go to employee 1 equal to new employee. So first, employee E1 will create this reference E1. New employee, new full-time employee will create memory for the full-time employee. And because we said employee E1 equal to, this will end up pointing to over here, right? Now let's go to the next line. Was hours work declared in the full-time class? No, it's being inherited, right? So let's take a look. What will the compiler do once it sees this? Remember, compiler checks what type it is. Not the actual memory, but what was the data type when it was declared. It will find employee. So where will it go to?
Employee class.
Is there hours worked? Yes. Okay, so that's all it needs to check. If there is hours worked, then once it generates the code, it will go to E1. Is there an hours work? So it will set it to 50 in this example. And of course, it will go to the set function over here, and the code for set will end up modifying it, but anyway. So the point is there's no problem in compiler verifying there is hours worked over here, right? Very similarly, let's come to this line over here. E1.manager equal to Johnson. What will the compiler do? Okay. Go to over here. Is there manager over here?
No.
So that's why I said this code won't even compile. So we will not write it like this, okay? So how will we write it? First we will say if E1 is full-time employee, we'll check. So how will this check work? We'll start from E1. It will go to the V table. We'll go to the type info, and there it will say the name of the class. Remember, one of the information maintained over here is name equal to full-time employee. So this will pass, right? Like I said, still we cannot do E1 dot manager equal to something. Okay, because if we did this, compiler will again say I don't see manager in E1, which is of type employee. Okay. So as we discussed last time, we have to create a reference which is pointing to the full-time employee, and then through that reference try to access the manager. So what we'll do is we will create a full-time employee reference. So let's call it full-time employee FTE equal to, and make it point to the same place E1 is pointing to. Okay, so now we are saying there's another reference called FTE, and what type it is? Full-time employee, and we are making it point to over here. Okay, same place where E1 is pointing to. However, as I mentioned last time, unlike Python or unlike JavaScript, where this type of thing will be perfectly acceptable, both C#, Java, C++ are strongly typed languages. In a strongly typed language, the type of the left-hand side has to match the type of the right-hand side. Okay? Unless we do typecasting, meaning we tell the compiler it's okay to do that. Okay? So what's the type of the left-hand side here? Full-time. What's the type of the right-hand side?
Employee.
So obviously there are two different types, so the compiler will not compile this if we wrote it like this. Okay, so to satisfy the compiler, we will say convert this E1 to also full-time employee, and that's what we call typecasting. So this is what we call typecasting. Typecasting is basically converting one type to another, and we always put whatever type we are trying to convert to within parentheses before whatever variable we needed to convert to another type. Okay. So anyway, now we are telling the compiler it's okay to treat E1 as a full-time employee. Okay. So now the type of the right-hand side is full-time employee, type of the left-hand side is, so the compiler now will say, all right, this is okay. Okay, now if we did FTE dot manager equal to, let's say, Johnson, it will work. Okay, why will it work now? What, again, if you are the compiler, what will you do? Check FTE. How is FTE declared?
Full-time.
Full-time employee. Then, since we are trying to modify the manager, what will the compiler do? Go to the full-time employee class, check is there a manager. Yes, so it will succeed. Good.
So if there is a private variable in the base class, so that won't be inherited in the derived class.
No,
And
private variables are inherited, but they stay private.
so if we call that private variable, like if we say e1.x is equal to something,
Protected.
See, so as we discussed, right, these are by default private.
yeah.
But if we wanted to access them directly over here, we cannot. So that's why, I mean, I didn't do it a proper job over
No,
here.
I'm just asking another question.
Okay, what was that question?
If there is a private variable, like if there is a private variable x in the base class,
Okay,
and now we are calling e1.x over there on the left hand side, e1.x, and we set it to something
E1.x.
like from getter and setters.
Okay, so
So-
you do have a getter and setter
Yeah,
over
we do
here?
have them.
So if the get and set is there, right?
So we'll say
E1 dot capital X equal
Yeah.
to something.
something,
Okay, so it will perfectly work.
but there is no entry for x in the heap area.
See, in that case, like I said, if once we do the inheritance, the X is also inherited. So once the computer allocates the memory, there will also be memory for an X over
Even if
there.
it is private.
Even if it is private. The only difference is, so you can directly, you can actually go home and try this out and you'll see it will work perfectly. The only issue will be if it is private, then you try to access, let's say you try to do in any of the methods x equal to x plus 1 as an example. Okay, it will complain that it cannot access it because it is private. But you can always go x equal to x plus 1 and it will work. Okay. So even the private fields are inherited. The question is, how do you access them?
Yeah. Excuse me, sir. What is the need for creating a base class reference? I mean,
Okay, that as I discussed last time, remember I was giving you an example of a drawing application and saving the data. So let's say you were creating a drawing application and you have a class called line. You have a class called, let's say, rectangle as an example. Okay, so you have a class called circle as an example, right? Okay, so now they have a lot of common things. So if you were to, let's say, have a menu over here, file, save. Okay, so suppose you have 3 lines over here, so you will create an array of line objects. You'll create an array of rectangle objects to save this, array of circle objects to save it. Alternatively, if all of these have a base class, let's say shape, you can simply create an array of shapes and store all the shapes in it. So as we do more advanced programming, going through a base class reference becomes a lot more manageable, makes us write less code. Otherwise, we have to keep treating each case differently. Okay.
And can we selectively call methods from the base class or the derived class? If we declare it
Anytime you are trying to call it through the base class reference, you have to use either the is operator or the as operator or reflection. Otherwise, you won't be able to call them. So let's pretend over here in the full-time employee class, we also have, let's say, one method over here, public double, let's say, bonus or compute bonus. So whatever the code is, right? And remember, this does not exist in the employee class. So how will we call this compute bonus? Again, through E1. Okay, if you try to do E1 dot compute bonus, will the compiler let you succeed?
No.
No. So again, why? Because the compiler goes by what is E1. E1 is employee, and there is no compute bonus over here. Okay. So again, we can either use the is operator, as operator, or reflection. So let me call it using the as operator now. So if I were to make a call to the compute bonus in the full-time class using as operator, what it will look like? It will look like full-time employee, FTE equal to E1 as full-time employee. So what does it do? As we discussed in the last lecture, you will start from E1, go to the vtable, go to the type info, check is it really full-time employee. If it is full-time employee, it will bring back a reference of FTE, already pointing to the same place where E1 is pointing to. So it does two things. You don't have to explicitly typecast if you're using the as operator. So it will automatically check. If successful, also give you a reference pointing to the full-time object, and you can call it anything you feel like it. Now through FTE, if you call compute bonus, it will work. Equal to, and whatever double bonus equal to. So anyway, just as a quick note, since some of you are coming from a Java background, Java also has exact same thing, except there is no as operator. There is an equivalent of is operator. There's an equivalent of reflection, very similar to what I covered in the last lecture. In Java, if you, rather than saying E1 is a full-time employee, you will say E1 instance of full-time employee. So the instance of is exactly like the is operator in C#. Okay. So anyway, so hopefully now you have a fairly good handle on polymorphism. Next week, as I start to give you bigger and bigger assignments, you'll get much better at this. So now let me cover one last part of basic object-oriented programming, which is operator overloading. Okay, so coming back to our basic OOP again. Okay, so once again, encapsulation, which you completely understand now. Inheritance, also everybody is very good with it. Polymorphism, even if it is a little bit confusing, don't worry. We'll be using it so much that after a few more lectures, this will be crystal clear. Okay, so polymorphism, as we discussed, can go in two separate directions. One is overloading, correct? And one is overriding. Overloading is done within the same class, correct? And the rule for overloading was the name of the method is the same, but the parameters have to be different. Okay, either the number or the type. Overriding is between a base and a derived class, right? So here we discussed, for example, one of the important concepts was that the base class reference can point to a derived class object. And once that happens, then there are further complications. And to resolve those complications, we have the is technique, as technique, and the reflection, correct? Okay. As far as overloading is concerned, now this further goes in two subcategories over here. Okay, one is method overloading. Okay, for example, if we create a class, see the constructor is like a method. We often overload constructors. We provide a constructor without any parameters. We provide a constructor with as many parameters as the number of fields in the class, right? Okay. We can also not only constructor, like we gave an example, if you wrote a compute AVG which takes the average of 3 integers as an example, right? The returns are double. Okay, can we have one more compute AVG in the same class which takes the average of 4 integers?
Yes.
Right. So that's called, again, method overloading or function overloading. Remember, method is another name for a function, with the difference being method strictly means it's a function belonging to a class, okay? Which in C# and Java is always the case, but in C++ you can write a function which does not belong to a class, right? Okay, so the second subcategory over here is called operator overloading. Okay, so let's take a look at that. This way our basic object-oriented programming knowledge will be complete. And next week onwards, we can go to the intermediate level topics. Okay, now just as a small point, in C++, operator overloading is supported. In Java, there is no operator overloading. Okay, C# does give us operator overloading with further 2 subdivisions further, okay? We have arithmetic operators over here. Okay, so for example, you know, plus, minus, multiply, divide, equal to, not equal to, less than, greater than. So all of these can be overloaded based on a given class. Okay, we can also overload the square brackets, because remember, once we create arrays, we index them through square brackets. Okay. So basically for arrays, we use square brackets, so these can also be overloaded. Now in C++, the overloading for both of these is sort of treated uniformly. C# divides these in 2 separate categories. When we overload the square brackets, the technical term is called an indexer. Okay, so think of it, you know, whatever index we put over here, that's the element of the array that we are trying to access. So index, so the overloading is termed as an indexer. Okay, so this is tiny bit complicated. This is very easy. So let me at least cover this part today, show you how straightforward it is. And then next lecture we'll cover the indexer. Okay, so before we go into operator overloading, the question is, Java decided against operator overloading, right? So is there a benefit to operator overloading, and why, for example, Java does not consider it that important? Okay, and the answer is, yes, we can live without it, but it does make our life easy. Okay, so in fact, one of the main purposes of operator overloading is it allows us to add new data types to the language. So new data types can behave as if they were part of the language, okay? Whereas without it, you will still be creating a class and calling, you know, literally dot add or dot subtract, you know, a method without the operator overloading. So anyway, so let's pick a simple example. Okay, many of you remember the complex numbers as an example, right? A complex number has a real part and an imaginary part, right? Okay. Now when we write, let's say, electrical engineering or you know, physics or any scientific problem, we often run into the need for complex numbers. Sometimes we need to add them, subtract them, multiply, divide, right? Is there a data type called complex already built into C#? No, okay? However, if we can do the operator overloading, it will behave as if this was part of the language, okay? So how do we do operator overloading? Let's say you will create a class called complex. You will declare double, let's say real, and the corresponding get set, okay? Double imaginary, and the corresponding get set, whatever that is, right? Okay, now what you will do is you will say public static operator plus. Okay, so before we write any further code, let's try to see how the user will try to create complex objects and how it will try to add them or subtract them, right? So the user will try to do something like this. Complex C1 equal to new complex, let's say 5 comma 7, meaning 5 plus I 7. So 7 is the imaginary part. Okay. If you are coming from the electrical engineering background, we don't use I, we use which symbol for imaginary? Anybody here? J7, right? And why? Because in regular math we use I, in electrical engineering we use J. Anybody knows the reason? Because I stands for what in electrical engineering? Current. So that there's no confusion. So that's why they use J. But anyway, it doesn't matter whether it's I or J. So somebody may want to create one complex number like this. Then they will create another complex number, C2 equal to new complex. Let's say 3 comma 8, right? So now the goal of the programmer is to be able to do something like this, C1 plus C2. Okay. So now again, let's pretend you are the compiler. Okay. So let's pretend this is all you wrote, and the two constructors over here, meaning a parameterless constructors and a constructor that takes the two parameters. Let's pretend you wrote those, right? So now take a look. If you were writing this code, what is this triggering? What part is it triggering over here? The constructor. Okay? And so if you already had the two parameter constructor, compiler will say it's okay. So this is okay, this is okay. Let's go to this line. Complex C3 just creates a reference called C3 equal to C1 plus C2. So see, this is where the compiler will check what is C1, complex. Then it will go to the class. Is there anything called plus over here? See, the compiler only knows how to add, as far as plus is concerned, integers or doubles or bytes, but it does not know how to add complex numbers. So that's why we'll come over here and say, oh, I don't know how to add, and we'll produce an error over here on this line, so this will not even compile, right? So this is where, if we can write a function over here to say how plus works on two complex numbers, then the compiler will call that function and it will work, okay? So let's go over here now. And let's add a method inside of our class, public static operator plus. So that's the syntax. Operator plus is the name of the functions, meaning this plus will correspond to this over here. Okay. Now when we add two complex numbers, what will be the reply? See, if we add two integers, what's the answer? What data type is the answer?
Integer.
It's still an integer, right? What if we add two complex numbers? The answer will be complex. So for example, if you did 5 plus I3, 3 plus 8, I8, right? So it will be 8 plus I11 as an example, right? So, so before we write the name of the function, we have to indicate what kind of data we'll be returning, right? Anytime we write a function, for example, if I'm writing compute AVG, right? What does this double mean? That the result will be double coming from this function. So anyway, so from operator plus, what will be the result? Complex. Okay. Now, second thing, how many parameters does it take? Whenever we add, how many things we are adding? 2. So there will be complex. Let me call it left-hand side. We can call it anything we feel like it. Complex right-hand side. The reason I'm calling left-hand side right-hand side is because this C1 will correspond to the, so it's on the left of the operators. C2 will correspond to the right of the operator. So it will be easy for us to see what code we are writing. Okay, so what will be the code over here? The code will be simply complex result equal to new complex. Okay, result dot real equal to LHS dot real plus RHS dot real. So we add the two real parts, and result dot imaginary will be LHS dot imaginary plus RHS dot imaginary. Okay, and then return the result. Okay, so this is the code in the complex class. Okay, so now whenever somebody writes complex C3 equal to C1 plus C2, compiler will check what is C1, it is complex, what is C2, it's complex. Then the compiler will go to the complex class. Is there a plus defined? Yes, there's an operator plus defined. So this call will be replaced by a call to this function. So result will come back with the addition of the two real parts and the imaginary parts, and we'll store it in C3, right? So now there will not be any error over here. Okay. So this is how easy the overloading is. So now let's say you did this, right? What if now you try to say in the next line, you try to say complex C4 equal to C1 divided by C2? What will happen?
We'll have to overload it again.
We'll have to overload again for the divide operator, right? Very similarly, what if you try to do complex C5 equal to C1 times C5, C2. Again, there will be an error, so we'll have to provide an overload of the multiply. Okay, so let me give you just quick code for the multiply, then I'll stop. And then I'll give you a small assignment for this week. Okay, so in the same complex class now, you will add one more method over here, public static operator multiply and complex LHS, complex RHS. Okay, again, complex result equal to new complex. So we'll create memory for our result, right? And then for multiplying, remember if you have A plus IB, C plus ID, okay? So we will do, for example, A and C, right, plus IBC, correct? Then IAD, and I times I is what? Anybody remembers? Minus one, so mine BD, right? So what's the real part? The real part is AC minus BD. What's the imaginary part? BC plus AD. Okay. So anyway, now we can say result dot real will be so think of A as our left hand side, A and B are left hand side, C and D are our right hand side. So AC will be left hand side dot real multiplied by right hand side dot real. C was the real, right? C was the real, okay. Minus left hand side dot imaginary times right hand side, sorry, not multiply but dot imaginary. Okay. And very similarly, result dot imaginary will be according to our BC, which is left hand side dot imaginary times right hand side dot real plus right hand side dot imaginary times left hand side dot real, right? And then return res. So anyway, that's our operator multiply. So now let me give you an assignment. Your assignment will be okay, so your first assignment will be, sorry, second assignment, right? Assignment number 2. Okay, create a complex class. Provide 2 constructors in it, just like I showed you. Okay, provide toString method. Okay, and of course, remember this will be an override from the object class. Okay, so you will say public override toString, just like we've done, right? And then you will overload all necessary operators. Okay, such as multiply, divide, plus, minus, equal to, less than, greater than, not equal to. Okay. Okay, and you will also write unit tests for it. Okay, how do we do unit testing? That's an important part of software development. So I will explain this in the next lecture. I'll go to the computer and show you how you do the unit testing, right? So this is part A. Let me also give you part B over here, and I'll give you a quick explanation. Okay, part B is create a currency class. And again, same thing, provide 2 constructors and an override of toString method. Okay, and overload all necessary operators. Okay, so what are the necessary operators? For example, divide does not make sense with the currency. Okay, multiply does not make sense with the currency. Okay, so these you don't have to do, right? Plus minus, we do add currencies, we do subtract currencies, we do compare them, right? So the other operators do make sense. Let me just give you a quick idea of this, 2 more minutes, then I'll stop, so that at least you can get started on it. So if you were to create a currency class, right? What will it look like? You will have int dollars and the corresponding public set get. You will have int cents and the corresponding get set, right? You will provide the 2 constructors, which you already are very good at. So let's take a look at public static currency operator plus Okay, and again, whenever we add things, we add 2, so there will be a currency left hand side, currency right hand side. Okay, static. Okay, so if somebody gave you, let's say, $5.20 and $7.90, what will be the answer? It will be $13.10, right? So as you can see, if the cent amount exceeds 100, we have to increment the dollar amount by 1, the sum of the dollars by 1. So this is pretty easy. So your code will look something like this: currency result equal to new currency. Okay, and then you will do res.cents. Since you are in the same class, you can use the lowercase. You don't have to use the uppercase. Cents equal to LHS.cents plus RHS.cents. Okay. If result.cents exceeds 100, greater than equal to. Okay, if it becomes greater than equal to 100, then what will we do? Res.cents equal to res.cents minus 100, right? So if it became 110, we will subtract 100, so it will become 10 cents. However, in that case, what do we have to do? Res.dollars equal to LHS.dollars plus RHS.dollars plus 1. Everybody agrees? However, if it did not exceed greater than 100, so it was 20 and 50, then the dollar amount should be simply added, right? So else res.dollars equal to LHS.dollars plus RHS.dollars, correct? So pretty easy, and return res. So this is pretty easy, okay? So now the complication will be, what if this is a minus? So subtracting currencies is not that easy, okay? Next lecture I can give you a few more hints, but today let me give you a hint. Easy way to subtract currencies will be, first, if somebody gave you $5.20 as an example, okay, first convert to total cents. Okay, so meaning multiply the LHS.dollars by 100 plus LHS.cents. So this will be the, let's call it LHS cents. So this is the total cents. So pretend this is a new variable. This is not LHS.cents, or so that it's not confusing, let me call it total cents. LHS, or LHS total cents. How about that? Okay. So very similarly, you will find right-hand side total cents by the similar formula. Multiply this by 100 and add this. Okay. Then in result cents will be LHS total cents minus RHS total cents. Okay, so in this example, what will it turn out to be? 520 minus 790. So this will be negative 270, is that right?
Yeah.
Okay, so now we convert it back to the dollars. Okay, how do we convert it back to the dollars?
By 100.
Okay, there is integer division. So you will say int res dollars, or you can say int res, sorry, you can say res dot dollars equal to res cents divided by 100. See, once we divide by 100, okay, if this is an integer, this is an integer, it does what is called integer division in C#, meaning it will not produce an answer of 2.7, it will only produce an answer of 2. It eliminates, if both things are integers, it eliminates the decimal and only keeps the real, the whole number. So this will produce in this example an answer of 2. Okay, so now we need the remainder after dividing by 100. We need the remainder. So we will say res dot cents equal to res cents res cents mod 100. Mod is a percent operator. So this percent operator, so for example, if you did 270% 100, it will return 70. Whatever is the remainder after the division. So that's called the mod operator. Okay, so in this example, what will happen? Both of them will turn out to be negative numbers. Okay, but then it will create a further confusion if after that you try to do a plus. So I leave it up to you to think a little bit how further to either to make only one of them negative, not both of them negative, so that if somebody tried to add this to another, so somebody did something like this, C1 minus C2 plus C3, it still should produce the correct answer. So anyway, we'll talk about this further, at least this week. Start on the assignments, part A, part B, and I'll give you more hints on Monday.